Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Determine a test on B1 and B2 that decides whether the system 3x minus 2y equals B1, 6x minus 4y equals B2 has a solution. Then state how many solutions it will have when it is solvable. And finally describe the column picture for B equals 1, 2, and for B equals 1, 0. Let's rewrite the system as a matrix equation, AX equals B. This makes relationships like one row is a multiple of another easy to spot.
To keep notation consistent, we'll use column vectors in the algebra, but in the R-squared pictures, we'll label vectors as ordered pairs.
The second row is exactly 2 times the first row, so the two equations are not independent.
If the left-hand side doubles,
the right-hand side must also double, or else we'd be asking for an impossible system. Elimination reveals the exact condition on B1 and B2 for consistency. The left side becomes 0 automatically, so the only way the system is consistent is if the right side also becomes 0. This is the complete solvability test. The system has a solution exactly when B2 equals 2 times B1. If the condition fails, elimination produces 0 equals non-zero, a contradiction. When the test passes, the second equation adds no new information. It's just a copy of the first one multiplied by 2.
One linear equation in 2 unknowns describes a full line of solutions,
so there are infinitely many solutions. Now, we'll parameterize the line of solutions. Write every solution using a free parameter. Choosing any real t gives a solution, and this formula lists all solutions whenever B2 equals 2 times B1. The column picture asks whether B can be built as a combination of the columns xa1 plus ya2. Will work in the B1, B2 plane. Each column is a vector from the origin, and B is the target vector we try to reach. Since A2 is a scalar multiple of A1, both columns lie on the same line through the origin. So the column space is just this one line, all vectors of the form T, 2T. Any combination xa1 plus ya2 must land somewhere on this line. Geometrically, solvability means B lies on the column space line. Algebraically, that's exactly the condition B2 equals 2B1. Same test, 2 viewpoints. For B equals 1, 2, the condition holds, so solutions exist. On the picture, 1, 2 sits right on the column space line, so it's reachable by combining the columns. Here's one concrete combination. Using only A1 with x equals 1/3 lands exactly on 1, 2. Because the columns are dependent, there are infinitely many other xy pairs that also reach the same B. For B equals 1, 0, the condition fails, so the system is inconsistent. Any combination of the columns stays on the line B2 equals 2B1, but 1, 0 is off that line, so there's no way to reach it, and no solution. The system is solvable exactly when the right-hand side matches the same times 2 relationship as the left-hand sides. Consistent means a whole line of xy solutions. Inconsistent means none. The column picture turns the algebraic test into a simple geometric check. Is B on the line? Watch the next video to learn more. Next, we'll explore how column spaces and consistency work in bigger systems and how to recognize them at a glance.